Now, we know it's there because we're breathing and we're alive. I want to start teaching you guys and the parents and everybody about the amazing world that God made, because it's not like that on other planets, and we want to know it's special. So I call this one The Wind's Wait. And you're going to see where those words came from. And I got to make sure I know how to do this. Okay. So today we did The Wind's Wait. If you guys come tomorrow, we're going to make slime. I don't know who likes making slime, but I like making slime because that's chemistry. All right, so you got to come back tomorrow. And some of you will get to make, I think we'll see if we have enough, make magnetic slime. If you haven't made magnetic slime, I think we may have enough for everybody. But we have glitter and food coloring, and we'll have little containers for you. It'll be fun. So that'll be tomorrow when we come at 7. So come at 7, we'll make slime, and then we'll have another talk in here with demonstrations. Now, if you come on Sabbath morning for church, we hope you'll come for that. I'll just have a talk with demonstrations, and in the afternoon, we'll do some more color-changing chemistry, and then we'll do another talk just like we're doing here with a lot of fun demonstrations that teach us about this amazing world that God made and some important things from the Bible as well. All right, so how do we show somebody that we love them? This is a deep question, you know, and parents like to talk about this for a long time. Some people think, oh, if you love me, you'll buy me something. No. Oh, that good. You've understood the picture, right? But some people think, oh, if you love me, you got to buy me something, right? But not always. As parents, we think, oh, if I love my kids, I want to keep them safe, right? So part of loving somebody is showing and doing things that keep them safe. And obviously with COVID, we've really thought about this. Now, this might be going a little overboard here with this kid. What do you guys think? Bubble wrap and a helmet. I'm not sure what the baseball bat's for. Yeah, maybe a bully or somebody coming. Yeah, so that's a little overboard. That's what I think. But the message is, one of the ways that we know that God loves us is that He protects us. But we sometimes don't know all the things that He's protecting us from until, because they're invisible, and then we need science and scientists to help us see some of that. Part of what I do as a scientist is help to see how God made this world, because there's a big debate. There's people arguing. They're saying, there is God, and He made this world. And then there's another group of people who are scientists who are saying, no, there's no God. If you give the world enough time, the molecules and chemicals, they'll bump into each other, they'll make little bacteria, and then those will make other things, and eventually fish, and then eventually lizards or something, and monkeys, and eventually that. So that's called evolution. And they say, oh, if you give enough time, it's called chance, like the roll of a dice. Eventually, if you roll enough dice, you get some amazing things that happen. And so I do not believe in that. I believe that God made our world, and I like to go around and teach people how to see that. Because even when I went to school, I went to Christian schools some of the time, and I went to public school some of the time, but nowhere did I even had good Christian teachers in public school, but no one ever taught me this, how to see God working in the world around us. So God's been teaching me this, and I want to share it with you, and there's some fun things we can do along the way. Now, in this big challenge, these arguments that people have, did God make it? No, yes, no, yes, no. People often want to have what? Oh, yeah, oh, sorry. I always forget about the fun part of this, you guys. Right there. You see the elephant? You guys see the elephant right there? Thank you. My Miss Viz, thank you. So there is an expression that says, there's an elephant in the room. And it's often when there's an elephant in the room, it's usually people don't want to talk about it, okay? And so there's an elephant in the room. We're going to figure out what the elephant in the room is. It's not just this. But you will see elephants on the screen. And I want you to count. So some of the pictures I show up here, some of the slides we call them, you'll see an elephant. Okay, this is the first elephant right here. Now, they're going to be this elephant, but I may change its color or its size. And I want you to see, I think it's not there. So we got one. I don't see one in there. Or that one. Oh, there. You guys see one? Okay. But don't yell them out. I want to see if you guys are paying attention. So we're up to 2. Okay, so I'm going to sneak little elephants on there. That was the same one, but I just changed its color. Okay, thanks. So we're up to 2. So when you see one, don't say anything. Just count. So now you got 2 things. You got to listen to me, and you got to count elephants. All right? And we'll see how many you guys can find. All right. So one of the things that a lot of people like to do is they'll say, oh, I found one thing that proves evolution or proves that God made this world. And I'm not trying to do that. I think there's so many reasons. There's not one. There's a lot. Because we often think that, oh, I'm David fighting the Goliath and these other people who are, and I don't like to get into arguments with other people. If they don't want to believe in God, that's up to them. But I think they should. And I think there's a lot of great reasons to do that. So we often feel like, both sides feel like we're David throwing our one little stone at each other. And let's not do that, right? We want to see all the different ways that God made that and our world. So I'm not trying to do that. All right, let's look at this picture right here. I don't see any elephants. But I want to ask you this question. Did some person make these stone columns right here? Or did wind and time erode away and make these? And so we're going to call this designed if a person did it, or natural if time and wind and made it. So how many people think it was designed by a person, these stones right here? Okay, we got a few people. How many people think wind and rain and erosion, natural causes did this? So we got a few people there. Okay, so let's talk about design. What can you look at that kind of makes it look like these guys were designed? What do you think, that if somebody built this?
Because they're separate stones.
Because it looks like they're separate stones? Okay, anything else? What do you think? Yeah. Like a small one underneath it and a big one on top? Something like that? I like the way that you're thinking, the patterns that's there. Now, let's go on this other side. What makes them look like they might have been eroded? Because erosion can do that. Like the wind and water, we know it can wipe away things. Now, this is not a great picture, right? Because it's sort of dark and you can't see. I'm gonna do a different picture of this, and then you're gonna tell me if somebody did this or was it wind and time. Okay, let's take a look at the next picture.
Somebody did it.
Okay, let's do a raise hand. Who says somebody made this? And it was designed by some people. Okay, how many people want to say time and energy and wind and no, okay. So what gave it away? What made this look like it was designed? Yeah, what do you think? It's super colorful.
They're colorful?
Yeah, the colors give it away, right? Nothing around that. Did you guys see the elephant? Okay. All right, there's an elephant now. Okay, I'm going to stop saying the elephant. So, yeah, do you guys see how tall those are? Can you tell how tall they are? Do you see that there's people walking around the bottom of those? They're like 40 or 50 feet tall. And it was designed by an artist, someone who thought about this. They had a crane, and they came and put this out in the middle of the desert. It's not too far. This is in Nevada. I forget how many miles away from Las Vegas. Now, Las Vegas, if you know about this town, lots of colors, lots of lights, and it's going all the time. So it's kind of connected to that. And I forget the name now. The 7 Majestic Mountains or something. We drove by this about 4 years ago, and it just stood out. And I was like, wow, look at that. Someone had to make that. Is exactly what I said. And I looked it up, and I thought, well, that's fun to see that. What you guys just did was using your knowledge and understanding of how things work, you were able to decide, did that get made by a person or not? And that's what we're going to try to do, is use that kind of thinking to decide if something's designed or not. Now, chemists, we look at things very weirdly, okay? Now, you look at this cup. A lot of people will say, that cup is half full. And if you say that, we say you're an optimist, because you always see the positive side. Now, some people look at it and say, that thing is half empty. We say that's a pessimist, that You have a negative outlook. You're not as happy sometimes. Now, a chemist sees that cup as full. Why? Why is that full? It only looks half full. Yeah.
Because half of it is water and half of it is air.
That's right. Half is water and half is air. You can't see it, but we know it's there. It rhymes with air. All right, and then engineers, there's a lot of other funny things in there. We're going to go on. All right, let me talk about cookies real quick, and then because we're going to talk about air. Cookies. Who's made cookies before? Okay, more of you guys got to go make cookies. If there's one thing you've made cookies, do you have a favorite cookie you like? Which ones? Chocolate chips. Yes. Now you can see these are mine. I like oatmeal with chocolate chips and raisins and other things. All right. Now, let's talk about making cookies. What goes into a cookie? I don't think that. What goes into a cookie?
Chocolate chips.
Yeah. What? Anything else?
Eggs.
Some eggs. Yeah. Good. Oats, especially my cookies with oatmeals. Yeah. Okay, adults, help them out. Flour. Sugar. Anything else? Salt. Sometimes raisins. Yeah. Okay, that's a fist bump time because no one else said that. Good job. Baking powder. Yeah. Sometimes cream. Some good smooth cookies. All right, so those are called the ingredients. Is that enough to make cookies? All right, so if I had all those ingredients and I threw them down on the floor, we've got cookies. What else do we need? Yeah.
We need to bake them.
We gotta bake them. All right, so I take all the ingredients and I throw them in the oven. We've got cookies. No. What else you gotta do? Measure. You gotta make the dough. You gotta mix the ingredients, right? You gotta mix. And all of those things that you're starting to now think about, you gotta make the dough. You gotta mix it. You gotta start to add it. You gotta put in the right amounts. And that's all before you put it in the oven, right? That is chemistry. That's what I think about all the time. I think about, oh, how did that get made? What are the ingredients? Okay, but ingredients is only one of the things. You also got to make sure you don't put bad things in there, like dirt. You're like, well, who would put dirt in there? Well, it's because you're good at making cookies. You know, no one's going out grabbing dirt and throwing it in there. So you're actually making a good decision, and maybe you don't put in mustard or ketchup or garlic. Oh, that might be all right. We've done that. Yeah, garlic's not too. So So this is what chemists do. We make sure we put in the right things. Did you know you probably shouldn't put in, 100-year-old eggs into that? No, right? So some ingredients get destroyed after time. And then we put in the right amounts of each. And we put them in the right order. You can mess it up if you don't put them in the right order. You mix them. And you put them in the right temperatures for the right amount of time. All of that's super important. That's chemistry. And then you need tools, right? Because if I were to do that on the floor, it'd be a lot harder. And it probably wouldn't work as well. Okay? And then we say it needs a person. It needs a mind. It needs intelligence to do all of that. Because I can't just shake my house and hope cookies fall out. Okay? Even if I did it for 100 years, cookies wouldn't come out. So this is what I call chemical design. Is you think about the ingredients, you think about the time, you think about all of the ingredients, and how much you need. Oh, and you did. So when you see gears like this, we think somebody put these gears together because they would not fit together if they weren't the right size and the right shape and stuff. So gears, those are something that people make. People with minds and intelligence, they do that. So, but that's the same thing with cooking. You got to have, they're like gears. If you got to have the right size, the right amounts, in the right orders, and connected all in the same way. So when I see chemical design, I want to make it as easy as I can. I look to see what happens with the ingredients. If I have too much, does it make it bad in some way? And what happens if you have too little? Does it make it bad in some way? All right, so we're going to do this with the air. So you guys are going to be scientists with me. We're going to figure out what happens if we have too much air or too little air. And I have never heard anybody talk about this. So we're going to do that. What if there was more air on our planet or less air? It seems like it would be better if we had more air, right? And you're going to find out not so much. Okay, let's see if there's some scientists out there. Our air has ingredients inside of it, different chemicals. Who knows, what are we breathing now? What are the different chemicals we're breathing right now? Okay, you've answered some questions. I'll come back to you. Can you guys, let's go back here. What are you breathing right now? Man, you say nitrogen? Are you a scientist? No. Most people leave that one out. Yes, there's nitrogen. In fact, that's the number one ingredient. 78% of the air is nitrogen. What else is in there? You guys know. What are you breathing that keeps you alive? Oxygen. Yeah, 21% of our air is oxygen. Does anybody know anything else we're breathing? A little bit of argon. You've been to my talks, I think, right? So, yeah. I don't have a good explanation. I think I know why there's argon. But, yeah, argon's third, and fourth is carbon dioxide. And over the last bit of time here, 50 years, it's been going up. But anyway, small amount. So those are the ingredients of our air. But, and I thought of them as bottles. Like if you had to split the air into 100 bottles, 78 of them would be nitrogen, 21 would be oxygen, and then the rest are in the small little bottle. All right. Now you guys work with crayons, and so we're going to think about the air that we breathe like crayons. Because you can have a little box of crayons, and you can have a big box of crayons. Has anyone had those big box of crayons before? Do we still do this? They have like sharpeners in the back. Have you had them before? Yeah, those are great. I always wanted them. I always had the little one, though. We couldn't afford the big box, and so they usually have like a sharpener in the back. Okay, so you know there's two different sizes, but they both have different colors in there, reds and blues and yellows. So we're going to do the same thing with our air. You can have different ingredients, that's the different colors, and then the total amount. Okay, so same thing with our air. We have a total amount of air, 1 atmosphere, and there's 4 ingredients. There's a lot more, but those are the 4 main ones. Now, if you were to fly over to Venus, which is next to us, it only has 2 main ingredients. There's a bunch of other things in there, but it is like the big box of crayons. It has 92 atmospheres of pressure. That means it's the big box. There is a lot more air on Venus. In fact, they say if you were to walk on Venus, it'd be like walking through water. The air is so thick there. But you couldn't live there because there's no oxygen. So you would die. But it's thick. It's heavy. It has a lot of weight. Now, if you were to go to Mars, it's just the opposite. Now, Venus, this weight is on top of you, and this is Earth here on the side. So it's about 92 or 100 times bigger. Let's go to Mars. Mars, there's no air. There's very little air there. It's about 100 times less than what we have. It is so thin there. So you couldn't parachute on Mars. Where they try to, when they're dropping rovers and stuff on there, they try to put a parachute out, but it's so thin it hardly slows it down. So there's very little air. And what it is there, it's mainly carbon dioxide and nitrogen, and so you can't breathe it. So just because you go to a planet doesn't mean it's like our air. It could be heavy with lots of air. It could be light. And so the way that we measure and think about it is that if I were to take this little wood piece right here, oh, here we go, and it's called 1 square inch, and imagine from the top of your head all the way to outer space, the amount of air that's in this little column, it goes up about 10 miles, and you were to weigh all of that air in there, it would weigh 15 pounds. And where did my 15-pound weight go? Did we have it? We didn't bring it over. No, you did. You brought it over. Where is it? All right, we're about ready to demo time. Oh, here it is. Here we go. Yeah. Okay, so this is like having 15 pounds of air on your head. Can you guys feel it? Can you feel that 15 pounds on your head? Oh, that would hurt. Well, you can't feel it. Why can't you feel the 15 pounds? Let's put it here. Why can't you feel the 15 pounds? Yeah.
Because it's very heavy.
Well, yeah, it is heavy, but why can't we feel it? What do you think?
Because air has no shape.
No, well, neither does water. But if you're to jump in water and you start going down deep, you can feel the water on top of you. The reason is it's because it's all around us. So on Venus, it's about 100 times heavier, and on Mars, it's 100 times less. So it'd be having like a really heavy weight on Venus. All right, we're going to help you see some air here right now. Kids that might need your help. We'll start with, should we start with let's start with this one right here. Who's going to do that, Christiana? All right. All right, so air is there and it has weight. Okay, Christiana, you're going to open this up. Now, someone put a nail, so you're going to hold it up high. Here, do we have a cloth? We're trying not to get the church too wet. Okay. Why don't you do it on the table here? It is dripping a little bit, but not too much. Okay, so Christiana is going to open this, pull this nail out, and we're going to watch all the water come out. Okay, are you ready? Go ahead and pull it out. Okay, she's pulling it out. You guys saw the nail in there, right? How come the water's not coming out? Isn't that crazy? Are you sure? Ah, there is a hole there. If you can't afford a squirt gun, this is a good way to do it. Okay? Now, if I open up the top, then the water will come out because that equalizes the air pressure. So we're doing an air pressure demonstration. Go ahead and put the nail back in. Carter, your turn. Okay, Carter said, he said to me a little while back, he says, Dad, you mean if I put a nail in the top, I could do the same thing if I tip it over? And he's going to pull the nail out. And he's not going to squeeze it, though. A little bit of water comes out. And then it stops. It's like magic, isn't it?
Yeah, my daddy does magic.
Oh, do you? All right. That is awesome. That's like doing magic right here. Okay. Then we thought, how big can we go? Cadence, are you going to do this one? Come on, Cadence. We thought, okay, how big can we do this? Let's go ahead and do this. Gentle, gentle. Careful. Here we go. You guys think the water's going to come out? I'm nervous. I'm so nervous. Did we put the it's coming out? Wait, it's not coming out. Wow! Thank you for clapping. I think it's awesome. Okay, if you let the air in the top, then it comes out. Okay, good. Thank you, dear. It's just water. It'll eventually evaporate. All right, so now we're starting to see that the air, the wind, if you would, has weight. You can go ahead and put it back in. Put the nail back in. And it can do things. Ooh, this is pretty cool. All right. Yeah, I think we'll do this one next, right here. Ooh, let's have a little fun with the air. Okay. What's inside this is a fun-looking flask. It's called an Erlenmeyer flask. And what's inside of it? Air. Very good. A lot of people say nothing. No, it's air. Okay, this is just a little piece of cloth here. A little tissue paper with some tape on it so it would fit inside there. Young lady, could you stand up here? And just blow this in there. Real easy. Come up here. Just blow that in. A little harder. A little harder. You got it. Okay. Wait a second. Wait a second. Is it broken? Wait, let me just make sure. It goes in there. You want to try again? Just blow it in there. Right there. Go ahead. How did you break that? I mean, it just goes right in there. Maybe we need a boy. Yeah, is there a young man here? How about you come here? Yeah. You guys got to do this earlier, didn't you? Okay, come here. Well, maybe I have to turn it this way. Okay, here you go. Come here. Here. Just blow it in. Okay. You did great. That's exactly what I was supposed to do. All right. You want to try one more time?
Yeah, okay.
Okay, all right. Blow it in there. Wow. You want to get that for me? Thank you. You can just put it right in there. Now, you may not have one of these at home, and you don't need to. You can just use it. This will work on a cup, but some of you didn't believe me. You wouldn't believe me if I did it right there. So I'm going to do it on a cup. There we go. Okay, so you can use a cup. And you just use a little thing. Whoa, how is that happening? How would you explain that? Using air. What do you think?
It goes behind the air goes behind it and
Pushes it out. Well, that's what it seems to happen. It's not quite what's happening. I got to teach you something. It's called the Bernoulli Effect. So you think it's going in. So if I were to blow it in, you should see it go in a little bit and then come out. But what you're doing when you move air, moving air is what we call low pressure. And inside, what will happen is that will become like high pressure. And then when it's high pressure, it will push it out. So moving air is low pressure, and where it's not moving, which is in there, is high pressure. Then it pushes it out. Now you can do some fun things with this. Oh, we need some paper. Need some paper. I forgot to get paper. All right, kids, can you guys get the fans going? All right, so we're going to create, we didn't get the hair dryer. We'll have to do some, and the ping pong ball. Too many things going on. All right, so Carter and Christiana are going to turn on the fan. So they're going to create blowing air. Okay? Now, the blowing air, okay, this is low pressure right here where the air is blowing. Okay, we got the other one going over here. So we got it on both sides. Now, the balloons look like they're trapped inside of the air stream right here. And the reason why they're trapped is that wherever there's moving air, that's low pressure, and the air that's all around it is high pressure, and that's holding them in there. Good job. It's fun. We had a little contest to see how many balloons you could get in there, and we found that those smaller, heavier ones do better on the bottom. The bigger ones are on top. Now, gravity's trying to pull the balloons down, and so the gravity's down, the fan's blowing up, but the reason why they stay in there is because of this Bernoulli effect. We got some paper? All right, the other thing you can do is with just a piece of paper, if I were to blow on it, it goes up, right? Now, what happens if I blow on it on the top? Why is it going up? If I'm blowing it, it should go down. What do you
I think the air is going under it.
No, I'm blowing on top of it.
It's because of air.
It's air. The moving air.
You're blowing the air, so,
Mm-hmm.
so when you blow, the air comes and pushes it up.
Well, there's air underneath here that's pushing it up. This is low pressure. Yeah, this is high pressure pushing it up. So you guys can do this up. Make sure you brush your teeth, though. I'm probably blowing mine. Okay. What else can we do with air? All right, you can do some more things with air. This is going to be hard. So we were playing around. These are called what?
Flip around models.
It's kind of. You do flip them around. Tornado tubes, because is this one the one that leaks? Yeah. You tightened it down. Oh, you can see the tornado in there. But what can I do to help show you air with this? Now, you see that there's water in here with some red food coloring, but what else is in here? What's in this part? Yeah, air. So what's happening in here is that you actually have air and water, right? And so the water, well, the water's down here. Now, this is actually really hard to do. Sometimes I can do this. That's not going to happen. But you guys can see the air now. The air is trying to get up. And it's trapped because of all that weight of water that's on top. But the air's trying to get up there because it's not as heavy. And so really what this whirlpool is doing is it creates a hole for the air to come up. And then the water can come down. You know that plumbers think about this, your toilet? And when you flush the toilet, it spins around so that the air can come out of the pipes, and then there's another place where they put a place for the air to escape. Because if you can't get the air out of the way, if you don't get the air out of the way with your pipes, then something bad can happen. The water won't go down. And I don't know if I can get it. That's hard to do. Dun, da, da. Yeah, thank you. I actually tried to make a video to show how to do this, and I was messing up. That's hard to do. What's holding it up? Air pressure, because the air has weight. It is just like a really thin liquid, and it does stuff. It does stuff. And it's holding it up. And as soon as I give it a little bit of a shake, then the air wants to get up. And eventually it'll go and you'll see it. But you can see the air, and the air does things, and it has weight. It has weight to it. Let's get this guy out of the way for a second. Okay, so that's fun. Okay, you're going here. Now, I have a special machine right here that can take the air out of something. It's called a vacuum pump. So I'm going to take the air out of this. Hard to get it sealed. There we go. Let's do this one. Isn't that crazy? Let's try another can here. Oh, it's coming apart on me. That's why I wasn't. Isn't that, see that can getting crushed? Why is that can getting crushed? What do you think?
It's because of the air blowing.
Where? On the inside or the outside? Where's the air that's crushing this? What do you think, young man?
So it goes into a machine, and then at the end of the car,
Uh-huh.
it brings air into the sky.
Well, the air is in the sky already, and what I did was I took the air out of this. And there's so much air around it where you can't see, but we're trying to, the air actually is what was crushing it. The air on the outside was crushing it because there was no air on the inside. So all I did was, some people think, oh, you're pulling the sides in. No, there's no air inside. So the air on the outside is crushing it. You can do some amazing things, as we'll show in the video. What did I do with the clicker here? What did I do with the clicker? Guys, it's hard being an absent-minded professor. Man, you lose things, and I was doing stuff. Did I put? Oh, I put it in my pocket. There we go. All right. Next slide. All right, you can do some amazing things with crushing air. Let's see if this will work. Yep. Okay, so there is a clever way to get the air out using a burner. And are these? Can everybody see the screens okay? Okay, so this metal can, they heated some water in it, and they boiled it, and that pushed all of the air out. So they basically took the air out using boiling water. It's a fun little trick. And then it gets crushed. The air on the outside crushes that can. All right, boom. Now, some people saw this and they're like, that's pretty interesting. They were able to crush using air pressure on the outside there a can. Could you do something bigger? There is a little bit of sound with this, you guys. Yeah, okay, we'll need that a little later. They did this in Japan. That is air pressure crushing that can. Now, there are other videos. Mythbusters did this. We're not going to watch them right now because we got to get going. And all of this air, there's a purpose to this air. It's not just for crushing cans. Rub your hands together for me. Tell me what you feel. What do you guys feel? What do you feel? Heat. Now, you guys don't need these things, but we call these the Michigan hand warmers. Because there's a part of the year we call winter. It gets cold. I don't know if you guys are familiar with this. But we are up, and so, we can warm ourselves. That is created from, what's happening when you rub things together? Friction. Friction. So that's because we know our hand is made out of material, and that hand is made out of material. You run materials together, they create friction. But isn't air real materials? Yes, it is. And when things go running through the air, you're creating friction with the air. Well, we're all pretty slow, and so we don't create that much friction. But if something's moving really fast, it can create a lot of friction. Let's watch this video here
Anderson Cooper
about something that went through the air really fast.
10 on CNN.
Let me turn this on.
The images look like something out of a movie. A tiny asteroid tearing through space at a speed of 33,000 miles per hour before streaking across southern Russia. Cameras caught sight of the white trail as it headed across the sky. And then this. An explosion of light, then a massive sonic boom. Strong enough to shatter windows and damage buildings. There were reports of more than 1,000 people injured, mostly from glass and debris. This video shows a children's judo class. Windows blew out here and in buildings around the region. Some people said they thought it might have been a plane crash. This is the aftermath of the blast in a high school. A 17-year-old student put this video on YouTube, showing the reaction in his physics class. Students screamed and ran into the hallways. He said some in the class thought war had started. Some of the incredible images were caught on cameras placed inside Russian cars. Many drivers now record their journeys in case of crashes or run-ins with police. Shock and gasps at the blinding light, the boom, and all the shattered glass.
Астероид. Реально.
Jim Bolden, CNN, London.
So in 2013, a really large piece of rock from outer space come running through the air. But it created friction and heat, and it exploded, and it created a fireball, and that explosion blew out windows and caused car alarms to go off and scared a lot of people. I don't think anybody died from this, but that was really scary, but also pretty amazing. Now, it turned out they originally started off as something that was as big as like a huge school bus of rock. And then as it hit the atmosphere, it burned up. And they found it in a lake. You guys see the elephant there? And it went from 20 million pounds to about 1,200 pounds. The air burned it up because it was friction and it burned up. And that's not too bad, although that's still pretty dangerous right there. But that big rock, whoa, that would have been really dangerous if that hit our Earth. So I asked the question, well, it looks like the air is protecting us. It's shielding us from these asteroids. And if we had more air, we would have more protection because we would have more friction. And so I thought, well, why don't we have more air for that? It seems like God would have done that for us. And then I also wondered, how are asteroids really a problem? And that was 2013. That was like 9 years ago. How often do these asteroids actually hit our atmosphere that would cause a really big problem? And the answer was in this video right here. So hopefully we don't get taken down.
The Nuclear Test Ban Treaty Organization monitors the Earth around the clock, listening for the infrasound signature of nuclear detonations. Between 2000 and 2013, this network detected dozens of massive explosions in our atmosphere. But not a single one of them was caused by a nuclear weapon. The actual cause, asteroid impacts. Between 2000 and 2013, there were 26 recorded asteroid impacts on Earth, ranging in energy from 1 to 600 kilotons. For comparison, the nuclear bomb that destroyed Hiroshima in 1945 exploded with an energy of 15 kilotons. While most of the asteroids shown here exploded at too high an altitude to cause damage on the ground, they do remind us that asteroid impacts are not rare. An asteroid large enough to destroy an entire city hits the Earth on average once a century. Because we don't know when or where the next major impact will be, our current strategy for dealing with asteroid impacts is blind luck. But we can change that. An early warning infrared space telescope for tracking asteroids would give us many years to deflect an asteroid when it's still millions of miles away. The next great space mission is protecting the planet. Join us.
Now, they're being a little, this is advertising for this mission that they want to do. But there is a lot of asteroids and meteors, 2 big ones a year, hit our atmosphere. And we hardly know anything about it because we're being protected from it. We need to just pause for a moment and go, wow, we're being protected because God put our air here. Now, there's a bunch of smaller ones that hit and they turn into small bits of dust. And so a lot of the dust that's in our air is actually from meteors as they burn up as they come in. 27,000 pounds every day. So it's not just you kids who are creating the dusty mess. That's just stuff falling from the air, okay? So there is a lot of things coming from outer space, but we're protected from it. And we don't think it's a big deal because it's not a big deal because we're protected. But we got to know that we're under a lot of danger there, but we're being protected from it. It's like the kid with the bubble wrap. Our air is like the bubble wrap that's keeping us safe from all of these. So it's our shield. It keeps us from hitting, from all those asteroids hitting us. Oh, it would be great if we had more air. But there's one other thing we've got to think about, our last thing right here. What else does air do for us? You know that when scientists are looking for life on another planet, they look for a certain chemical out there. Does anybody know? What do you think? Not oxygen. I would think they would look for oxygen. Look for something else first. H2O. Oh, wait, is that H2O? That's chocolate. That's the search for intelligent life. We're just talking about life in general. No, they look for water. So water is what they look for. But it's not, well, they would love to find any kind of water, but really life needs liquid water, not frozen and not as steam. So liquid water on a planet's actually really rare, and you need something special for this to happen, and it has to do with air. Now this video is me doing something with this water. I think it'll go here. Click it one more. Oop. What? I think there's let's just a quick little video. I'm doing something to this water. What's going on? How am I making that water boil? What do you guys think I might be doing? Yeah, it's a little thing called a Bunsen burner. There's a flame underneath it. You may not be able to see it too well. But I'm boiling water. Who's boiled water before? Yeah, most people. Okay, the kids, when you get to college and you're doing ramen noodles, you'll do a lot of boiling of water. Okay, it's very dangerous, right? And so we got to be careful with it because boiling water is really hot. And did you know that you can change the temperature of the boiling by changing the air that's on top? So the bubbles that we see when things are boiling, that's water turning to steam and leaving. So in this little chart right here, we're going to see that water boils at 100 degrees Celsius when you're at sea level. And as you go up in mountains, the water boils at a different temperature. In fact, it's a colder temperature. And the higher you go, the less temperature you need to put in, the less heat you need to put in to boil it. At the top of Mount Everest, water boils at 70 degrees. The important thing that I want you to see right here as our last thought is that water boils, turns into steam, depends on the air that is with it, on top of it. Okay, so how are air and water connected? From the air. So I have a little demonstration. I am now going to, I think that's coming up here. So air and water are connected because of the boiling point. Let's take a look at this water right here when I take away the air from on top of it. Now we saw when I took the air away from this that it crushed. Now this is a special glass right here. It's very thick and it's round. The air wants to crush this. So I have to be careful. I've done it a number of times. This one seems to be pretty sturdy. So I'm going to take away the air that's inside. The rest of it's going to crush, but we're going to see something interesting. That's boiling water. I'm boiling it. Now, is it hot? Do we have a brave soul that wants to come and touch it to see if it's hot? Come on up. A couple of you guys, come on up. See if you can touch boiling water. Go ahead and touch it, just real quick. Is it hot?
Cold.
In fact, it's kind of cold. Okay, go ahead and sit down. That is boiling water. Isn't that crazy? You guys can say you touched boiling water. That's sticking right there. Isn't that amazing? It's cold, kind of cold, isn't it? It's not hot. Yeah. The air, the weight that's on top of the water changes the boiling point. And if I take away all of it, it would boil away. Let's put the air back in. And then it stops boiling. Boiling isn't just from the heat, it's from the amount of air that's on top. If we didn't have the air, the water would boil and turn into steam, and we wouldn't have any liquid water on our planet. Yeah. They're still going. I thought I turned it off, but yeah. Let's talk about this as our last thought. The less air we have, water would boil. But it changes the boiling point. In fact, some of you guys do this. Anybody got a steam cooker? Steam cookers at home? Pressure cookers? Sorry, wrong word. Pressure cooker. The pressure cooker does the opposite. Instead of taking away the pressure, it puts in more pressure because it's all traps the steam in there. And so the boiling point actually gets higher for water, and you can cook things faster. So the air controls the boiling point of water, which actually controls the water cycle. If we had less air, all the water would turn into clouds, and we wouldn't have any rivers and lakes. If we had too much air, then it would keep all the water down as lakes and rivers, and it wouldn't evaporate into clouds. You see, the water cycle purifies our water. Otherwise, it would start building up with salts and minerals, and you couldn't drink it. We have to have this purification process that is taking place, and that is all related to the air. So when God designed Earth, he said, I have to put in the right amount of air. I want enough to protect my special children. And I want to have just the right amount so that the air can be purified with an automatic cycle that's going on. And so he thought about all of those things as he put together. And so all of these things, as a scientist, I start to think about gears. How are they all connected? The air pressure is connected to the water cycle and to our protection. And we're going to see tomorrow night and our other days how some of these other things connect together. Because that's what chemistry can help us to do, is to see how they're all connected. Because they are all connected. And I'm not going to go through all of them right now. Okay? They're all connected as gears. Now, where did I get the title? The title for tonight was The Wind's Weight. And this is from Job 28:25. And God's talking to Job, or they're talking about God and what he did to make this world. And he said, when he gave the wind its weight, and apportioned out the waters by measure. I love how there's wind and water and it's all connected, and he made a decree for the rain and a way for the thunderbolt. God thought about the wind and its weight when he made this. And I wanted you guys to see the invisible, because the air is all around us and we just think it's invisible and doesn't do much. It's not only keeping you alive, it's protecting you. And it's keeping water as a liquid. And all of these things, all of these ingredients have to be tuned so this can happen. And I wanted you guys to see that. So that's it for tonight. But how many elephants did you guys count? How many? 16? Okay, let's hear some other numbers. Go ahead. 15? How many did you guys, ladies, get there? 19? 14? Or some other ones?
16 or 14.
Somewhere in there? 12. How many? 20? Okay. 12. 17. Okay, we're all getting different numbers. That's interesting. What did you get? How many? 20? How many did you get?
I forgot to do mine, but
You were focused on the information that you were thinking about it. Yeah, that's me too. I lost count. All right, how many? No, I don't think we did those other slides. I think it's 19. I think it was 19. Maybe 19 or 20? Okay, it might have been 20. Sorry. Okay, I think it was 20. If you got 19 or 20, we don't have a prize. We need to bring prizes. But good job. You were paying attention. You might get some marshmallows or something tomorrow night. All right. So the elephant in the room that nobody's talking about is the air. Okay? It's all around us. It's big, and it's heavy, and it has weight. And that's what, when you think of air, I want you guys to think of an elephant. Okay? That it's, right? It's big, it's heavy, it can protect you. It also can be dangerous. All right? You can crush things like an elephant. So that's the air. Now, this elephant has a special name, and I'll introduce his real name tomorrow night, okay? Because he has another name, but he's part of the air. In fact, he makes most of the weight of the air. And so that's what I want you guys to think about. And this is my new guy here that I've got. Now, one other thing. What color shirt is he wearing? Purple. Now, this is from my basketball team that was called Purple Haze. And on Fridays, the Hayes family will wear purple. Right, guys? Carter. All right. Now, if any of you guys wear purple tomorrow, you got to re-wear your shirt tomorrow. Yeah. We will have a little bit of candy for you guys. Some dark chocolate, probably. Yeah. M&M. No, it'll be. So we just like to do this. I do this with my college students, and they don't care. so they don't wear purple. Because they want points, they don't want candy. But we'll bring a little piece of candy if you guys wear purple tomorrow, and we can get a lot of people wearing purple. That way we celebrate Friday as we're getting ready. There's a long story to it, won't get into it now, why we're doing it. But it was just fun. It was fun. So we're going to wear purple. We actually have special Purple Friday shirts that we wear. So if you guys want to do that, that would be fun. Wear some purple tomorrow night. We'll start back in the Fellowship Hall gymnasium over there at 7. We're going to make slime, so we'll do that for the first 20, 25 minutes. And then have another talk with a bunch of other demos we're going to learn a little bit more about our air, okay? Thank you so much. If you don't mind, I would like to pray. We're in a church, and I want to thank God for making this amazing world, because every time you breathe, you think about elephants, and you think about how God is protecting you, keeping you safe. All right, let's pray. Father God, you're amazing, and you thought about all of these things and a whole lot more when you made Earth, and you put your special people here. And so we want more people to know how amazing you are, and that you are real, and you really love us, and you protect us all the time, and we thank you for that. We know that bad things still happen, and that's why we need your loving servants to come and help and take care of people. And we know that sickness and sin is still there, but like Jesus and the vitamin C will come in and clean us. That's amazing. So thank you for thinking of all these things, and for these people who come out of their busy schedules to spend time together here thinking about you in this amazing world, because we don't want to miss it. And we don't want to miss you, because we know that you're coming back very soon. And please bless us as we go home now. In Jesus' name, amen. God bless you guys. If you have any questions, you can come up and ask them. Oh, yeah, if you want your papers, I think you can go back into the gym there and grab your papers. If you don't want them, just leave them there. Please don't. We're going to clean all that up. Just leave it there when you get done, because it's all got to be cleaned up a special way.
How many of you guys enjoyed tonight? Raise your hand.
I did.
Yes, thank you, Dr. Hayes and your family. If you enjoyed tonight, invite a friend for tomorrow night.
Yeah.
Don't forget to come tomorrow night as well, and invite some friends to come and share and
Yay!
Good.
Have a great night.